Imagine a company runs 5 different applications, and to keep things secure and organized, each one is installed on its own dedicated server in the company's data center. So we have one web server, one for the email system, one for file storage, one for a database, and one for a business intelligence tool. At first glance, this setup might seem clean and reliable, but it's actually inefficient. Why? Most of these servers are sitting idle most of the time, only using a fraction of their capacity. Yet the company still pays for power, cooling, hardware, and maintenance for all 5 machines. With virtualization, we don't need 5 physical servers anymore. Instead, with the help of a hypervisor, which we will discuss shortly, we can run multiple virtual machines on a single physical server, meaning each of our previous applications, the website, email system, file storage, database, and business intelligence tool can now run on a single server, optimizing resource usage and reducing costs. Each virtual machine behaves like a full independent computer, but they all share the same physical resources. The company can now consolidate all those 5 applications onto a single or fewer servers, reducing costs, power usage, and complexity while improving flexibility. But we can take this even further. What if we don't have to own or manage any servers at all? Cloud computing takes virtualization to the next level. Instead of running our virtual machines in our own company's data center, we can run them in massive shared data centers owned by providers like Microsoft Azure, Amazon Web Services or AWS, or Google Cloud. And now, we don't need to buy hardware, worry about power outages, or manage physical security. We simply rent computing power and storage when we need it over the internet in most cases. This shift allows businesses to move from capital expenses, such as buying servers, to operational expenses, such as only paying for what we use, while at the same time gaining greater flexibility, speed, and global reach. Okay, let's begin this video chapter on virtualization and cloud computing by first looking at what we are about to cover. We will start by defining virtualization, examine how server virtualization works, and discuss its key advantages for businesses. We will then define cloud computing and understand how it builds on virtualization. Next, we will break down common cloud service models such as IaaS, PaaS, SaaS, and the different ways cloud can be deployed, such as public, private, and hybrid. We will then cover the basics of interacting with cloud environments using concepts like tenants, subscriptions, and resources as examples. Finally, we will delve into the modern paradigm of serverless computing, focusing on function as a service, event-driven architectures, and their benefits illustrated through a practical example. And just a quick note, this is chapter 6 of a larger course titled Introduction to Information Technology. Let's get started. So what is virtualization? Virtualization is the technology that allows businesses to make the most out of their IT resources by creating virtual versions of physical resources like servers, storage, or networks. These virtual resources behave like standalone physical entities but are not tied to specific hardware. This is achieved by separating the physical hardware of a computing device from the software that uses it with the help of a virtualization layer. So how does virtualization work? We will look specifically at server virtualization, where we can run multiple virtual servers on a single physical machine using something called a hypervisor. There are 2 main types of server virtualization. First up is type 1 hypervisors, also known as bare metal hypervisors. We start with the physical infrastructure of a single server. This physical server or host provides the foundational hardware. So we're talking about CPU, RAM, storage, and networking. These resources will be essential to powering the virtualization environment. Next, instead of installing an operating system directly on the server, we install a special layer of software called a hypervisor. This hypervisor sits directly on the hardware and manages multiple virtual machines on the server. So on the slide, we can see 2 virtual machines or VMs hosted by the hypervisor on a single server. A virtual machine or VM is a software-based emulation of a physical computer. It acts as a standalone system with its own operating system, applications, and resources, but it relies on the hypervisor to access the underlying hardware. The operating system that is run inside the virtual machine is called the guest OS. The hypervisor ensures that the VMs are isolated from one another, providing security, stability, and flexibility. This setup is widely used in data centers and cloud computing because it provides high performance and scalability. Now let's look at type 2 hypervisors, also known as hosted hypervisors. Here, the hypervisor is installed on top of an existing operating system like Windows or Mac OS instead of directly on the hardware. This allows users to create virtual machines within their local environment. This approach is more common for personal or small-scale environments rather than enterprise data centers. Type 2 hypervisors are useful for software testing, development, and running different OS environments on the same machine, but they are not as efficient as Type 1 hypervisors because they rely on the host operating system. Let's look at some advantages of virtualization. With a VM, we can run different applications on the same server, for example, one for finance, one for HR, host different operating systems on the same server, for example, Windows on one, Linux on another, and ensure portability. For instance, you can move a VM from a Dell server to an HP server without compatibility issues, ensuring uninterrupted service during maintenance. Some of the top virtualization vendors include VMware, which is a leading provider of enterprise-grade virtualization, known for its robust and scalable solutions. We've got Microsoft Hyper-V, which is built into Windows Server, making it easy for businesses already using Microsoft products. Citrix, known for desktop and application virtualization. And Oracle also offers virtualization for enterprises, especially for those using Oracle products. Now that we understand how virtualization lets us run multiple virtual machines on a single physical server, let's take it a step further. So imagine you've virtualized your company's data center. Great. You are now using your hardware more efficiently, spinning up VMs for HR, finance, sales, and DevOps, all on just a few servers. But there's still a catch. You are still responsible for everything: buying hardware, powering and cooling the data center, maintaining the network, handling backups, securing the systems, and scaling for peak traffic. Compared to the initial one application per server setup, yes, you have now improved efficiency, but you are still managing the infrastructure. Let's push the boundary further with cloud computing. So what is cloud computing? Cloud computing allows businesses to access powerful computing resources over the internet or mostly over the internet. It builds on virtualization, but instead of managing your own infrastructure, you rent it on demand from a cloud provider like Microsoft Azure, Amazon Web Services, or Google Cloud Platform. With cloud computing, you no longer need to buy physical servers, maintain hardware, or plan for overcapacity. Instead, you provision virtual machines, storage, and services in the cloud, pay only for what you use, and scale instantly based on your needs. At its core, cloud computing is an evolution of the traditional client-server model. In a typical setup, a client device like a desktop, smartphone, or IoT device sends a request to a server, which processes the request and sends back a response. Cloud computing builds on this idea, but makes it more powerful and flexible by adding two key innovations. So first is virtualization, which you have already seen. So instead of one physical server handling one task, cloud providers use virtualization to run multiple virtual machines on a single server. This allows better use of hardware and easier management of resources. And the second is distributed computing. Cloud systems are spread across many physical servers in multiple data centers, often in different parts of the world. So when you use a cloud service, your request doesn't just go to one server. It goes to the best available resource in the cloud network. This allows for massive scale, speed, and reliability. For instance, if one data center becomes unavailable due to a natural disaster, our request will be automatically routed to the next available data center. Cloud computing offers technology as a service delivered over the internet, so businesses don't have to buy and manage everything themselves. This concept is often described as everything as a service. There are three main service models, each offering a different level of control and convenience. We have infrastructure as a service or IaaS, platform as a service or PaaS, software as a service or SaaS. To understand the difference, think of it like outsourcing. The more you outsource, the less you manage yourself. Let's start with a baseline where nothing is outsourced. In an on-premise setup, a company manages everything in its own data center. Nothing is outsourced. Internal IT teams handle hardware, networking, software, and maintenance. So, for example, a business can host its own ERP system on servers located in its own data center. Next, we have infrastructure as a service. With IaaS, businesses rent computing resources such as servers, storage, and networking from a cloud provider, but they still manage their own applications and data. An example would be a business hosting its own custom inventory software on Microsoft Azure virtual machines instead of running physical servers. Next is platform as a service. With PaaS, the cloud provider manages hardware and software platforms, so businesses can focus on developing applications. They don't worry about servers, operating systems, or runtime environments. So basically, we can just write code and deploy. An example would be a business which builds a reporting dashboard using Google App Engine without worrying about server configuration or patching. And we have software as a service. With SaaS, businesses use applications that are fully managed by a cloud provider. No installation, maintenance, or infrastructure management is required. An example would be a sales team using the Salesforce CRM application through a web browser and over the internet. Cloud computing isn't one size fits all. Depending on a company's need for security, control, and flexibility, there are three main primary ways to deploy cloud services. We have public cloud. In a public cloud, services like storage and computing power are provided by a third-party vendor, such as Microsoft Azure, and these are shared across multiple organizations. And don't worry, your data isn't mixed with others. Cloud providers use advanced security and isolation techniques to keep each organization's resources secure and separate. The advantage is that it's cost-effective, scalable, and fully managed. You only pay for what you use, with no need to maintain physical infrastructure. An example would be a business running its website and storing data on AWS without owning any servers. Next is private cloud. A private cloud is only used by one organization. It can be hosted in-house or by a dedicated provider, but the key is that the resources aren't shared with anyone else. This is ideal for companies with strict security, compliance, or performance requirements, such as those in banking, healthcare, or government. An example would be a financial institution hosting its core systems in a private cloud managed within its own data center for maximum control. And then we have hybrid cloud. A hybrid cloud setup combines public and private clouds, allowing companies to split workloads based on sensitivity and scale. So you get the scalability and cost savings of the public cloud for non-sensitive workloads while keeping critical data and applications in a private environment. So a company could process customer transactions in a secure private cloud, but run its marketing website on the public cloud to handle traffic spikes during promotions. Now that we understand what cloud computing is, let's look at how it's actually structured behind the scenes using Microsoft Azure as our example. And don't worry, these concepts apply to major cloud platforms like AWS and Google Cloud as well. To work effectively in the cloud, it helps to understand three key concepts: tenants, subscriptions, and resources. Tenants are the top-level containers for Azure services, and they help manage access to the services we intend to use. For an organization, a tenant represents the company's dedicated Azure environment. It is tied to an instance of Azure Active Directory or Azure AD, which is a digital directory that is used to manage users, identities, and access permissions across all services within the tenant. Subscriptions define how we organize and manage our services in Azure. Within a single subscription, we can deploy multiple services. Each subscription is associated with a specific billing account, meaning Azure will invoice us based on our subscription. Subscriptions are also tied to a particular tenant. For example, if we manage both test and production environments in our general company IT space, we would need to create separate test and production subscriptions in Azure, all within the same tenant. And we have resources. Resources are the actual services and products we deploy, such as virtual machines, storage, databases, and more. And multiple related resources in the same subscription can be grouped together within a resource group for easier management. So for instance, if we need to deploy an API, we can use Azure API Management or APIM. This is a service where we can host and manage APIs with billing based on the usage, such as number of API calls or the resources consumed. Now that we have explored the foundations of cloud computing, let's take it even a step further with a powerful and modern execution model, serverless computing. Despite the name, serverless doesn't mean there are no servers. It simply means you don't have to think about them. With serverless computing, you write and deploy code, and the cloud provider takes care of everything else. You only pay when your code is actually running. Function as a service or PaaS is the most popular type of serverless computing. In this model, you break your application into small single-purpose functions that are triggered by events. These functions don't run continuously, only execute in response to specific events, and automatically scale based on demand. This leads to high efficiency and cost savings, especially for applications that have unpredictable or sporadic workloads. In PaaS, an event is anything that happens in your system that can trigger your function to run. Examples of events include a user submitting a form, a file being uploaded, a new row being added to a database, or a scheduled time, say for a daily report to run at 6 a.m. Your function only runs in response to one of these events. So there is no server running in the background 24/7. Major cloud providers offer their own serverless or PaaS solutions, such as AWS Lambda, Azure Functions, and Google Cloud Functions. Now, let's conceptualize a simple PaaS solution with the aim of understanding how the various components such as events and functions can come together. For our business case, our goal is to provide our sales reps with real-time access to daily special rates via a custom tablet app, which is pulling data from an on-premise database. Let's look at the flow. First, the sales rep opens the custom tablet app. The app sends an HTTP GET request to the APIM endpoint. APIM authenticates and authorizes the request. If authorized, APIM forwards the request to the Azure function. The Azure function is triggered. It uses a data gateway to connect to the on-prem database. The function will execute the SQL query, and it will format the results or return set as JSON. Next, the Azure function will send this JSON response back to APIM, and APIM will forward the response to the tablet app. And in the last bit, the app will pass the JSON and will display the daily special rates to the sales rep. Let's look at the business benefits of PaaS in this particular scenario. So first, you only pay when the function runs. There is no cost for idle time. The system adjusts instantly whether you have 5 or 500 reps checking rates at the same time. There is no need to update or monitor any servers. Azure handles it all. And developers only need to focus on the function logic and not the general infrastructure. And that brings us to the end of this video. To summarize, we have gained an understanding of the foundational and modern aspects of cloud computing. Here are some key takeaways. Virtualization optimizes usage of resources, consolidating multiple applications on fewer physical servers to reduce costs and complexity. Cloud computing offers on-demand virtual resources, eliminating the need for physical server management and providing scalability and flexibility. Cloud service models vary in control, with IaaS offering the renting of hardware, PaaS focusing on app development, and SaaS delivering fully managed software. Cloud deployment models such as public, private, and hybrid offer different levels of control to dedicated or mixed environments. Cloud platforms organize resources into tenants, subscriptions, and resources, at least in the case of Microsoft Azure, for efficient management and scaling. And finally, serverless computing, and in particular PaaS, allows businesses to run event-driven code without managing servers, reducing costs and complexity.